Welcome back to week 3, and in video 2 we are going to talk about sedimentary rocks, how they form, and some of the major steps to identify them. So, what are sedimentary rocks? Well, they're solid particles, so they are a solid rock that's composed of those loose sediments we talked about in the last video, or biologic material that was deposited in a low-lying area like an ocean basin or a lake, things like that, and then it solidifies into a solid. So you can see down here the pictures of this loose sediment where you can pick up and feel the different particles in your hand, and then the solid rock where you have to pick up the whole thing and you can't actually break it apart very easily. So how do sedimentary rocks form? Well, through this process of lithification. And lithification means basically that you're taking these loose sediments and you're compacting them together and then you're cementing them together. So then I crude drawing down here, we've got these loose sediments, for example, maybe that build up in a riverbed over time. And as more and more layers are deposited on top of these original loose sediments, we're adding more and more weight on top, and because we're adding more and more weight on top, we're actually taking those loose sediments, we're compacting them together. We're getting rid of a lot of that open space that originally existed. As we add more and more weight, things are going to get squished and settle in together more and more. So it's compacting the sediments together, and then eventually, over time, we have those void spaces, these white spaces, fill in with some type of cement, and that's what the red symbolizes in that last image. And cements can be silica or quartz, or it could be calcite, and we can also have maybe iron oxide helping to hold those sediments together as well. So basically, all of those things, iron oxide, the calcite, the quartz, can be dissolved in water, and that water can filter through these sediments, and then over time, as that water sits there, some of those cements start to precipitate around those grains and fill in those spaces. This is it takes a significant amount of time. And you can have some sedimentary rocks that are kind of borderline between sediment and sedimentary rock that break apart really easily. You might have one in lab that breaks apart really easily. You'll find you rub your fingers on it and all the sand comes off. That's because that rock isn't cemented very well. There's not a whole lot of cement holding those particles together. So what are you going to do in lab? How are you going to identify the different sedimentary rocks? Well, just like with igneous rocks, you're going to look at the texture and the composition. So when we look at the texture, you're going to look at the grain size, the grain shape, and the grain arrangement. And then in composition, we're going to look at detrital, chemical, and biological. It's very similar to what you looked at with the different sediments. So, grain size, we've got some major categories. Clay, smallest particle. The rock's going to feel pretty smooth to the touch. You might see that the clay particles are kind of layered on top of one another. And again, you're not going to be able to see the grains with the naked eye. Silt is kind of the next step up. It's in between sand and clay, so maybe feels a little bit gritty, but not quite. Can't really see the particles with the naked eye. Sand, you can actually start to see those particles, and sand can have a pretty wide variety in the grain size. There can be maybe 1 millimeter to 2 or 3 millimeters in the size of those sand grains. And then pebble, we're going to have pebble-sized particles or gravel-sized particles that are going to be at least 2 to 3 centimeters in size, so much larger particles that you can see. And then boulder, we're not going to have these in class. Cobble would be the size of the sample that you're going to have. So when you're determining grain size, you're going to determine if it's clay, sand, or gravel, or pebble. So grain shape, angular, rounded, or kind of in the middle. That's what subangular and subrounded mean. So here I've got a couple examples of angular grains. We can see these shell particles have some pretty sharp angles on the edges, and then down here, these particles here, this one's square. We can see some pretty sharp sides to some of those particles. Whereas this image over here on the left has pretty round edges, and this would be considered a rounded particle, all of these guys in here. So rounded versus angular. And then you're going to look at arrangement. Do you see a random mix of particles? No organization pattern at all, these two on the left here? Or do you see that those particles are layering or organizing themselves into nice layers? So these would be some good examples of clay particles that are layering up on top of one another. And then of course composition. So you're going to determine if you have a detrital sample. So does it have rock fragments? Usually the rock fragments, you can either, if it's coarse enough, you can tell there are other rock fragments just by looking at it, or if they're a little bit smaller, might have a kind of a grayish appearance. Detrital also includes quartz and other minerals, like feldspar is going to be pink. Quartz can be white in color, it can be gray in color. If there's any iron oxide, it might take a kind of a reddish or a pink color as well. And then chemical, so these are going to be rocks that are going to be forming from some type of chemical reaction. So you're not going to see rock fragments. Halite's a good example. You're not going to see any type of biologic activity present. You're not going to see any fossils. So here, if you have a biologic rock, you're going to be able to tell that there are fossils present, carbon present. Those would be two examples of biologic rocks. So on your sheets, you're going to tell me if it's detrital, chemical, or biologic, and then you're going to tell me what mineral you think is present in that rock. And I'll give you a hint. A lot of your biologic rocks are going to react to acid because they have calcite present, because that's what shells are made of. So those are major ways to identify sedimentary rocks and what they are and how they form. So we'll come back in the next video and talk about the history of a sedimentary rock and kind of what that tells us about the environment that was once at that location.